Hello, welcome to this lesson. This is 2-3, and today we're going to talk about tangent lines. Tangent lines. How do I make a line that is tangent to a graph? I'm going to go ahead and talk about the things that you need in order to make a tangent line. The first thing that we're going to go ahead and talk about are derivative notations. Now, there's several ways to indicate a derivative, and they're all used pretty commonly. So, given a function y equals f of x, the derivative of y equals f of x can be written as f prime of x. And this is how it is read, f prime of x. So that little apostrophe right by the f, that indicates that you are taking a derivative, f prime of x. Now, sometimes a function is not always a function. It can be an equation. So instead of f of x equals x squared plus 2, you can have y equals x squared plus 2. So we also have y prime. That is also fairly common. And these are both products of Isaac Newton, Newtonian notation. This is how he communicated in mathematics that this is a derivative. Well, calculus is allegedly made up at the same time by two people, the other mathematician being Gottfried Leibniz. And Leibniz notation indicates a derivative in this manner. dy over dx, or read as dy dx, also read as the derivative of y with respect to x. And that one is a little bit more tedious, but it is also more informational. We'll dive into the importance of Leibniz notation later on in our course. Okay, so we're going to just first be able to use those notations. And now we're going to go ahead and write equations of tangent lines. So a derivative, what this does is it tells us the slope, or the instantaneous rate of change of the line tangent to a function at a given point. It's the instantaneous rate of change at that point. Okay, so what we're going to go ahead and do is we're going to write equations to tangent lines. Now, the important thing to remember is that a tangent line is just a line. It's just a line. And in order to write a line, you need two things. You need a point. Okay, you also need slope. Point and slope, you can create a line. Okay, and you should be able to remember that from your days in Math 1. We always talked about y equals mx plus b. Didn't you always plot your b value first when you graphed? And then you went ahead and used the slope? So, same idea. Okay, a point. So, writing the equation of a tangent line of f of x at x equals a. Well, I need a point. Now, usually they give you an x value. In this case, they give us x is equal to a. So my point is going to be a. And oftentimes, they don't like to give you the y value. So what we have to do is we have to use our function f. And then we're going to evaluate at a. Okay? So, plain and simple, that will be our point. And I also would like you to write this, x1, comma, that's a comma, x1, comma, y1, our point. And I'll show why we're doing that here in a second. And then slope, we need our slope. Well, this is the derivative of f prime. F prime where? Because the derivative is instantaneous rate of change. Well, what's our x value? A, so f prime of a, okay? So, once we have point and slope, we can go ahead and generate the equation. Now the equation, what I'm going to do here is I'm going to go ahead and give you point slope form. Point slope form. So the equation that I want you to use is y minus y1 is equal to m times x minus x1. Okay? Y, that's just going to be your y value, your output, the equation of a line, minus y1, that's going to be the y value that you found from your point, is equal to m. Hey, that's your slope. M equals slope. I know, earth-shattering news. Times x minus x1, and again, your x1 value is the x value of the point where we want to find the tangent line to. Okay, so let's go ahead and look at example number 1. if I can find example number 1. Okay, example number 1, it says a function f of x is continuous and differentiable for all values of x. It is known that f of 4 is equal to 7 and f prime of 4 is equal to 2. Write an equation of a line tangent to f of x at x equals 4. Okay, well, they want us to go ahead and write the equation of the line tangent. That's just a line. I need 2 things. I need a point. So I need an x and a y. Well, in the prompts, don't they say that f of 4 is 7? So they gave us, there's x1, there's y1, there's your points, 4, 7. Given. Guaranteed, this will be on the AP test. You need a point and you need a slope. Second thing, slope. What's my slope? Well, don't they say that the derivative at 4 is equal to 2? So there's your slope. 2. Okay, so what's the equation of a line? Well, y minus y1, that's 7, is equal to m, which is 2, times x minus x1, which is 4. There's the equation of a line. You're done. That's it. Don't try to simplify it. Leave it like that. That is your equation of your line. Example number 2. The function g is defined as g of x equals x squared minus 3x plus 5, and it's known that the derivative of f is defined as g prime of x is equal to 2x minus 3. Write the equation of the line tangent to g of x at x equals 1. Okay, equation of a line. I need 2 things. I need a point. Okay, so what's my point? Well, they say x is equal to negative 1. Negative 1. There we go. But what's my y value? They don't tell me. But they do give me the function. Don't they give me g? G of negative 1. I can go ahead and plug this in. Negative 1 quantity squared minus 3 times negative 1 plus 5. That's going to be 1 plus 3 plus 5. That's 9. Negative 1 comma 9. Okay. Number 2. Now I need the slope. Well, they don't outright tell us what the slope is, but they do say that g prime is equal to 2x minus 3. So my x value, though, that I have is negative 1. So g prime of negative 1 is 2 times negative 1 minus 3. Okay, so that gives us negative 5. I have my point, I have my slope. Now I can go ahead and I can write the equation to my line. Y minus 9 is equal to negative 5 times x minus negative 1, which becomes a plus. Right? Y minus y1 is equal to m times x minus x1. Pretty straightforward, right? Pretty easy, Okay. Ooh, a table. Yes, I love questions with tables. They're so fun. It's better than Easter. Better than an Easter egg hunt. The function h of x is differentiable for all values of x with selected values of h and h prime in the table above. Example number 3. Write the equation of the line tangent. Oh, they want me to write the equation of a line. At h of x, or to h of x at x equals 1. Okay, well I need 2 things in order to write a line. I need a point and I need slope. So my point, well, again, they give us an x value, 1. Now I need my y value. Well, what is h of 1? I'm just going to go to my table, okay? Here's 1. And then what is h of 1? Negative 5. Negative 5. Okay, so I have my point. What's my slope? Well, that's h prime. At what x value? At the same x value. That's the slope at 1. So that slope is, according to the table, negative 4 right here. Here's h prime. So our slope is negative 4. Okay, so y plus 5 is equal to negative 4 times x minus 1. Done. Very straightforward, right? All you need, right, are two things. Find two things and you're good. Okay, I want you to go ahead and pause me. I want you to try example number 4 on your own. Write the equation of the line tangent to h of x at x equals 2. Take a second, pause me. I'll show you the answer here in a second. All right, hopefully you paused the video. This one had a little bit of a curveball, but if I need to go ahead and find my point, well, again, they give us -2, and h of -2 is 3. They give us that, no problem. Our slope, h prime at -2 is equal to 0. Oh, a slope of 0. What's a slope of 0? Isn't that a horizontal line? It's a flat line. Flat line. So, couple of ways you could write this. I'm going to go to what we've been doing. So the equation of a line would be y minus 3 is equal to 0 times x plus 2. If you write that, boop, there you go, you're good. There's the equation of a line. Now 0 does cancel everything out, and so aren't you left with just y minus 3? Well, that would also be y is equal to 3. Okay, it's a horizontal line. Horizontal lines are y equals. All of the y values are 3. So anyway, either of these would be acceptable. Did you get it? Good job. Okay, example number 5. Example number 5 is difficult just to be difficult. And it ties back into our first lesson on the limit definition, specifically the alternate limit definition. So let's go ahead and read the problem, and then we'll dive into how the alternate limit definition comes into play. Example number 5. Let k of x equal x squared plus 5x minus 3. Write the equation of a line tangent to k of x when x is equal to 3. Sure, this isn't difficult. I just have to find my point. You're right. 3 is your x value, and then your y value is k of 3. So k of 3 is 3 squared plus 5 times 3 minus 3, which gives us, I believe it's 21. 9 plus 15, yeah, 24 minus 3, 21. So there's my point. Okay, no problems. Slope. What's the slope? They don't give us k prime. In this one, they don't tell you what k prime of x is. And I have not taught you yet how to find k prime given a function. I will teach you. That's coming up in the next couple of lessons. So slope. How do I find the slope at a point? Well, only if I had taught you a way to do this with a limit. I did the limit definition, the alternate limit definition at a point. The limit as x approaches 3 of f of x minus f of 3 over x minus 3. So this tells us the slope directly at 3, and it's on the board right behind me. I don't know if you picked up on that. It's right behind me. So I'm going to go ahead and do this one. This is building, recycling your skills from the last lesson. Oh, this should be 3, f of 3. Okay, so f of x, what's f of x? X squared plus 5x minus 3. There's f of x. Oh, and you know what? I gotta include my limit. The limit as x approaches 3. Okay, minus, and I'm going to highlight this just so you can see. I'm substituting in f of x. Here is, oh, you know I did this last, I taught it too. It's not f of x, it's k of x. So k of x, here's k of x. I'm just substituting that right here. Minus, now I need k of 3. K of 3. Okay. Minus k of 3. And k of 3 we found, here's k of 3, wasn't that 21? So I can put, okay, minus 21. There we go. All over x minus 3. That doesn't change. And the structure of these problems is the same. You're going to get your function value combining with your actual function. And that's going to give you a factorable quadratic. So if I look here, -3 and -21, doesn't that give me a -24? You said yes, right? Good. Equals the limit as x approaches 3 of, and now I'm just going to go ahead and factor it. Isn't this x plus 8 times x minus 3? Divided by x minus 3. Okay, so these cancel, and we get the limit as x approaches 3 of x plus 8, which is 3 plus 11, or 3 plus 8 equals 11. There's our slope. Our k prime of x is equal to 11. Whew! Man, crazy. Okay, so I have my point, I have my slope. Y minus 21 is equal to 11 times x minus 3. There you go. There you have it. All right, the next example uses a calculator. So you'll want to go ahead and have access to your calculator. And they say the function p is defined as p of x equals the natural log of x squared plus 7. Write the equation of the line tangent to p of x at x equals e to the power of 2. Okay, line tangent, I need two things. What are the two things that I need? A point. Very good. They say x is equal to e squared. Okay, e squared, there's my value, but I need a y value. So what I'm going to do is I'm going to use my calculator, and I'm going to try to put this in the screen. Let me see if I can get it. Let's see if we can fit this. Right, here we go. Okay, so I'm going to define my my function. So I'm on the calculator page, menu, actions, define. Okay, actions, define. I'm going to define p of x is equal to the natural log of x squared plus 7, I believe it was, plus 7. Plus 7. Okay, done. All right, so now I need p of e squared. So what I'm going to do is I'm just going to use my calculator. I'm going to say, okay, what is p of e squared? Do not punch in e on your keyboard. Your keyboard does not like e. It needs to be the function, or the mathematical function e, the number 2.718 approximately, e to the power 2. Let's see what this is. Notice how it gives me an exact answer. I'm going to hit Control Enter to get an approximate answer. So 4.121. 4.121. Let me minimize that and document. Approximately 4.121. Okay, and now I need the slope. So how do I find the slope? Well, that's going to be p prime at e squared. Okay, so I got to use my calculator to take a derivative. So menu. I'm in calculus. We're going to calculus. We're doing calculus stuff. Number 2, derivative at a point. So x is my value, or my variable. My value is going to be, again, e. And notice it says exponent in the parentheses. I'm going to put 2 because that's what the input is. E to the power 2. I'll hit OK because it's the first derivative. And you'll notice it says, here's the Leibniz notation. The derivative with respect to x of what? And here's where you just input your function. P of x at x equals e squared. I go ahead and enter this, and this gives us, after I go ahead and correct it, let me move me over here, you'll see we get 0.240. 0.240. Okay, so there's our slope. So the equation of a line, y minus y1, 4.121, is equal to our slope, 0.240 times x minus x1, which is e squared. There you have it. That is writing equations of lines. Writing equations of lines. I hope you learned how to write the equation of a line in this video. What are the two things you need? You said point and slope, right? Very good. All right, give me a thumbs up on this video. Subscribe to get some more awesome math content. I'll catch you in the next video. See you later.